show to you that on our unit circle, which you can review in other videos, it's another very correct circle, we showed that the y for any point x, y on the unit circle is equal to the sine of theta, which is a trigonometric function, relating to this angle here that we kind of, you can imagine flipping up this part of the x-axis and making an angle in between, and that this x-coordinate for this point that it intersects is equal to the cosine of that angle. And at the end of the video, I said that really all of this is the Pythagorean theorem, and I want to kind of elaborate more on that, and because I think it was unclear. So the Pythagorean theorem, if you don't remember, is that the hypotenuse of a triangle, let's draw one, of a right triangle, h equals a and b, that h squared is equal to the sum of a squared and b squared. Alright, so how does this compare to this? Well, in a unit circle, the radius of the circle, which would be the hypotenuse, is always equal to 1. So let's make an equivalent statement after erasing this model here. Let's make an equivalent statement in red. So if r squared, which is the same as h squared here, is equal to this y here, because that's the equivalent of b, and this x, which is the equivalent of a, is equal to x squared plus y squared. Let's plug in some known values. So r equals 1 for 1, so 1 is equal to, alright, so x squared would be cosine squared of theta. Cosine squared of theta. And you put it, the squared symbol between the cosine symbol here and theta, weirdly. It's just a convention, but it's the same as here. It's basically the same as the more familiar approach, cosine theta squared. They're equivalent statements, plus, and it's the same for sine theta, sine squared theta, because y we've shown is sine theta. So this is very interesting. The sine squared of some angle plus the cosine squared of that angle in the unit circle is equal to 1. Okay, but again, the unit circle is just this, little worthless circle of radius 1 that isn't, too interesting. So how does this apply to more triangles? So let's think of any triangle. So in any triangle, this isn't exactly the case where this, it's not exactly the case that r equals 1. So how would it be different? Let's take a look. Alright, so if we just have some random right triangle here, it's got a right angle, so we know we can use trigonometry for it. And there are ways you can use trigonometry for other kinds of triangles, but we're not going to get into that today. So if we have a triangle like this, how can we write the Pythagorean theorem equivalently? Well, we can say, right, that r squared is equal to y squared plus x squared. That's not new. But this time r isn't equal to 1. And so y isn't equal to sine theta, because as we recall, the sine of, let's say this angle here is what we're using. The sine of this angle is the ratio of this far side here, which happens to be y, to the radius. So it's essentially what we multiply times this radius to find our y value, the side across from it in this right triangle. So we could say, because of that y is equal to r sine theta. And it was only true that this was equal to sine theta only because r is equal to 1, so that just canceled out. And it's the same thing for x. X is equal to r cosine of theta, which is instead the ratio of the adjacent side to the hypotenuse r here. And so we multiply times r to find the adjacent side. So here are some values. Let's input these in instead of y equals sine theta and x equals r cosine of theta. So instead we can say that r squared is equal to r squared sine squared theta plus r squared cos squared theta, cosine squared. And let's solve for this. So what happens if we divide both sides by r squared? Well, we get that 1 is equal to sine squared theta plus cosine squared theta. And this is what we are looking for. So our statement is still true. The sine squared of any angle plus the cosine squared of the same angle is always going to be equal to 1. And this pops up a lot, sine squared plus cosine squared of theta, in later maths, and it's in a very important thing known as a trigonometric identity. And that's kind of a fancy term for an important truth about trigonometric functions that you should know, that you should essentially memorize. You should know how to define it, of course, but memorization is fine because it will come a lot up in later maths. Thanks for watching.